this video, we are going to talk about sets. What do you need to understand about sets? First of all, before going anywhere, you need to understand what a set is. So what is a set? A set is a collection of well-defined objects. It's a collection, or rather a list of well-defined objects. And these objects that are comprised in a set, we refer to them as members or elements. Just as simple as that. Yeah. We move on to methods for describing a set. So we have two main methods of describing a set. So a set can be defined either by listing the elements explicitly or by specifying the properties that are determining that same element or that same set. So we have, first of all, roster or listing or tabular form. So we have roster, listing method, or tabular form. So this is a type of method that elements, it's a common one, the one you know. So in this kind of description, elements are described by being separated with commas. So they are enclosed in braces. So an example of roster or listing method or tabular form is this one here, the universal set. So you understand what I mean by universal set shortly. So this is an example of a roster or tabular form, also known as listing method. The second type of method is a rule method or set builder method. So a set builder method is it just tries to list a set by identifying the properties that determines the elements in that set. I hope that's clear. So roster, listing method, or tabular method is a type of set that defines a set by listing them and separating them by commas, with commas. And then when you talk of rule method or set builder method, this is a type of description which specifies a property that determines the elements in a set. So an example of a set builder or rule method set is this one here. So this one here and this. So C, B, and yeah, these are set builder kind of description. So what is B telling us is saying X is a member of N. So this N, you understand, it stands for natural numbers. And then they are saying such that X is less than 19. So this is a set builder kind of description. So moving on to that, that's what you need to know about definitions and set notations. I'll try to talk about some of the signs or letters that you're going to find in a set using the example here. First of all, you need to understand the types of sets. I won't talk much about the types of sets because that will be a tutorial on its own. So we have a universal set. So a universal set is denoted by U. This is a universal set, as you have seen there. So what is a universal set? So a universal set is just a set consisting of all possible elements which are under consideration or which are being talked about. So, and it is denoted by U. So it is denoted by U. Yeah, so let me just read through the example and we try to tackle this, and most of the things will be talked about. So given that u, which is the universal set, is equals to that, x is equals to even numbers, y is equals to prime numbers, z is equals to whole numbers, and b is equals to that, and c is equals to that. So some of the symbols that are being used here, you need to know them. And it will be hard for you to answer this question if you don't know those symbols. Well, that's the importance of this video. It's just mainly to describe this. So first of all, you need to understand what are natural numbers and the sign that is used to denote natural numbers. So the n, or rather the n, mathematicians will disagree to say this is not n. So this denotes natural numbers. This denotes natural numbers. So what are natural numbers? What are natural numbers? So natural numbers, these are just counting numbers. So these are counting numbers, 1, 2, 3, and going on. And then what are we also find whole numbers. So we have whole numbers. Whole numbers are denoted by W. So they are denoted by W. These are whole numbers. So these ones we've said they are counting numbers, isn't it? Counting numbers. What do I mean by counting numbers? So we are just talking about numbers starting from 1, 2, 3, and going on. Then what are whole numbers? So whole numbers, these are just all natural numbers, including a 0. So these are just all natural numbers, including a 0. So these are whole numbers. So all natural numbers, including a 0. So these ones start from 0, 1, 2, 3, and going on. We also have integers. What are integers? These are whole numbers and their negative counterparts. So integers are just simply whole numbers and their negative counterparts. So they are denoted by Z. Yeah, like I said, mathematicians would disagree that this is not a Z. So Z. And what are they? We've said these are whole numbers and their negative counterparts. So when we talk about whole numbers and their, so meaning they are these and the negative ones. So we're talking about -2, -1, 0, 1, 2, going on, and also going this to infinity. Yeah, and what else is being used here? We also find what are prime numbers. You know, most of us, we ignored these lessons when we were learning, like I said. So we have natural numbers, or we have even numbers, odd numbers, prime numbers. You need to know them. They are very, very important. So even numbers, an even number is any integer that is divisible by 2 without leaving any remainder. So what do I mean? Any number that is divisible by 2 without leaving a remainder. So even numbers, examples of even numbers we have 2, 4, 6, 8, 10, and going on. So any number that does not leave a remainder but divisible by 2. So 4, 8, and going on, you know these things. So odd numbers, what are odd numbers? Odd numbers is any integer that is not divisible by 2. Any integer that is not divisible by 2, meaning it leaves a remainder of 1, or yeah, it leaves a remainder of 1 when it is divided by 2. So what are these numbers? These are numbers like 1, 3, 5, 7. So note that 0 is not an odd number, because 0 is divisible by any number without leaving a remainder. So prime numbers, what are prime numbers? So prime numbers a prime number is a natural number greater than 1 that has no positive divisor other than 1 and itself. Is that clear? I'll repeat that. A prime number is any number that has no, sorry for that. So a prime number is a natural number greater than 1 that has no positive divisor other than 1 and itself. So the only divisor is 1 and itself. So examples of prime numbers are 2, 3, 5, 7, 11, 13, and going on. So those are some of the things you should know. Write them down if possible. Write them down. I insist. Let's now look at this example. So given that U is that, so U, like I said, stands for universal set. So U stands for universal set. So X is equals to even numbers in U. So you see, like I was saying, they'll just say X stands for even numbers in U. If it's in an exam, then you'll be dataless, or you'll think heaven has gone very far from you. So this is how they bring questions, exactly just like this. So if you don't know what even numbers are, you face hell. Let's try to identify these sets. So X is equal to even numbers in U. So X is equals to even numbers in U. So you know what even numbers are. What are even numbers? We've talked about it. So even numbers are any numbers that are divisible by 2, or any integer that is divisible by 2. Okay, so knowing what X is, so we can say X is equal to, so negative numbers are also even numbers because they are divisible by 2. So negative 2, 0 is an even number because 0 is divisible by 2 and it doesn't leave any remainder. So we have 2, 0, and negative 2, and 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So these are the even numbers we have. These are the even numbers we have. Okay, so we move on to Y. So they are saying Y is a set of prime numbers. What are prime numbers? So we said prime numbers is a natural number greater than 1 that has no positive divisor other than 1 and itself. So what are natural numbers? Natural numbers, we said, are counting numbers. So meaning negative numbers are not prime numbers. Another reason to give you why a prime number cannot be negative. So let's say, let's get a positive number that is only divisible by 1 in itself. So we take, for instance, 3. So 3 is only divisible, positive 3 is only divisible by 3 and 1. So 3 itself is 1. But let's take, for instance, we get negative 3. So this negative 3 can be divisible by negative 3, negative 1, 3, and 1. So this does not fit the definition of a prime number. So that's why we say a prime number is a natural number greater than 1 and has no positive divisor other than 1 and itself. Clear? So what numbers are prime numbers in here? So we have 2. So 2 is a is a prime number. Why? Because 2 is only divisible by 2 itself and 1. So we have 2, 3, 5, 9. 9 is not a prime number because 9 can be divisible by 3. So 9 is not uh, a prime number. So we have 7, we have 11, we have 13, have 17 and 19. So these are prime numbers. So we move on. We go to Z. We go to Z. So they're saying Z is a set of whole numbers. And we said whole numbers are natural numbers including 0. So we know that whole numbers are natural numbers including 0. So we're simply going to start from 0, 1, 2, 3, and going on. And going on up to 20. Yes. We move on to B. So you remember this type of notation or this type of description? This is called rule method or set builder method. So a set is just described based on its properties. So B has, they're saying B is a member. So B has element X, and X is a member of natural numbers. So you know that this set only has natural numbers such that X is less than 19. So what are natural numbers? Natural numbers are counting numbers. So natural numbers are counting numbers. So B is a member. So B has X, and X is a member of natural numbers, and such that X is less than 19. So we are simply going to start from what are natural numbers? Counting numbers. So we're simply going to start from 1, 2, 3, going on up to, so they are saying is less than 19, not less or equal to 19. So 19 is not part of that set. So 18, we even close. We move on. We go to C. So C, they are saying C we have as X, and X is a member of what? Z, I said, is what? Z are integers. So what are integers? Integers are just simply whole numbers and their negative counterparts. They're just simply whole numbers and their negative counterparts. So we take that. C is made of integers such that negative 2 is less or equal to X less or equal to 17. So what they are trying to tell us to say, negative 2 should be less or equal to X, meaning we have our starting point. So X is a member of integers, so our starting, so meaning they're just telling us this X should be less or equal to this X should be greater or equal to negative 2, because they're saying negative 2 should be less or equal to X, meaning the X should be greater than negative 2. And then this same X is less or equal to 17. So they've given us the interval. So we are going to start from negative 2. Why? Because it's less or equal to. So negative 2, negative 1, we have 0, 1, 2, 3, 4, 5, 6, 7, going on up to 17. Up to 17. So that is how you describe those sets. So that is how you describe those sets. Yes, due to time, for now we are going to end here. We're going to end here.